yet. Twitch is a little slow today. There we are. We are streaming. A little slow is like 4 seconds. I remember back in ye old days when we had to wait 10 or 20 seconds. Anyway, streaming game dev. Gonna do, what do you want to call it? Flow depositing? What's it called? Sand stuff. Paste. I did a small amount of complaining about the term cloud, and that tweet seems to have taken off. So I won't really be able to tell if anybody tries to tweet at me regarding this tweet, because it's going to be buried under things about that tweet. Fun. Doesn't matter. I'm going to be paying attention to this. So the last episode, what we did is we spent a little bit of time trying to figure out how we could make this rock structure look good. And what we did is we piled up sand on one side, we dug sand out on the other side to try and give it the right feel. I didn't do it very aggressively because I didn't want to waste too much time. And then what we did is we put a lot of particles down underneath it. I'll show you that if it ever plays. But the idea is that in the sheltered spaces, there are more particles than you might expect, more plants. So what we're going to do today, I think, is we're going to make a helper program that does exactly this, but without needing me to do anything manual. And the way to do that is fairly straightforward. I'm going to probably have to change this to... We'll work it out later. The way to do that is fairly straightforward. We just need a new thingamabob, a new script that can be attached to a rock. So let's go ahead and try it. Here's our script. Here's our level design area. So we can paste in a new script. I got some spam. So let's go ahead and block this guy. Block. Block. Unfortunately, blocking him doesn't seem to remove him from the chat. I'm just going to hit reload, because that'll clear him from the chat, for me at least. All right. So, there we go. So what we're going to do is we're going to create... Oh, great. I clicked away. Thank you, spammer. You screwed up my my clicking here. Come on. All right, so we're going to want to have, we'll call it a Lee maker. So when you're talking about the lee of wind, it's the part behind the rock. So basically what we're going to do is we're going to have this get pointed at a target, and then we'll have it create a pile of sand on one side and a gap on the other side, and then pepper the underside with plants. So the problem is, I don't remember where we can find the terrain class, and it doesn't look like anybody wants to autofill here. Hey, look, there's an update I need to get. I know you're shocked. You're just amazed. It is just called a terrain, but no, it should just be that. I guess problem is that we're not properly synced. Yeah, there we are. Finally, you've turned on. All right, it was too busy telling me that it needed to update, so it took it 10 or 15 seconds to catch on that we wanted it to actually do something useful. All right, so we're going to need to know the terrain. We're going to need to know the collider. And we're going to have to know the direction of the wind. Left. And so to make sure that we can visualize this, we're going to just draw a couple of values. So public, no, sorry, it's just void, on draw gizmos. I haven't done any work today in terms of programming, so I am not on top of the ball, but we should get there. Let's adjust the mic. Let me just double check that we actually have mic. Yeah, okay. Seems fine. So with OnDraw Gizmos, we're going to want to draw what rock we're talking about and what terrain we're talking about and all of that. We're not going to bother with the terrain. We're going to draw the rock and the wind vector. So if target, then we're going to draw a wire frame. Draw a wire sphere around target dot center dot bounds dot center. There we are. And then the radius is going to be target dot bounds dot, and it doesn't actually have a radius here. There's no radius function, but there is an extents dot magnitude. Extents dot magnitude divided by 2, because I believe that extents dot magnitude is, actually I can't remember. Sometimes these things are halved and sometimes they're not. I can't remember which is which. We'll go ahead and leave it like this for now. And then we're also going to want to gizmos.draw a line from target.bounds.center to target.bounds.center plus wind direction times 5. Otherwise, we're going to want to draw it around ourselves. We're going to want to draw something around ourselves anyway, just so we can find ourselves. So we'll go ahead and use our own target for that, just our self. Transform.position and 3. And then down here, we'll just draw the line from where we are instead of the target. Like so. And that'll actually start right away giving us an idea of the sort of things we're looking at. So we've got this kind of floating cube. What was I using that for? In 15 or 20 seconds, it'll finish compiling here. All right, so this floating cube doesn't appear to be used for anything. It probably is just something I was using to... Oh, I was using it just to show you where the 0 point was. I don't need that anymore now that I understand that it's screwed up in a very specific way. So what we'll do is we'll remove the box collider here. We'll leave the mesh renderer because otherwise we're going to have issues with not being able to find the object in question. But what we'll do is we'll drop the Lee Maker onto it like this. And you can see that immediately it gives us a different sort of setup than, it gives us a visual that we can see. In order for us to get the same flow here, it looks like rather than right, it is forward. So there we are. And that's going to be the direction. But what we can do is we can drop in a couple of important values. First off, we want the terrain. Boom. And then we want this as our target. We can select it and then just drop it in here. And you can see how that immediately goes and circles it. And you can tell that it's substantially larger than it should be. The bounds are ridiculously big. Oh, that's not what I wanted. It's up here. And that's because half the time the bounds are measured from the center and half the time they're measured from side to side. Either way, you can see that now we've got that rock circled. And this here is a little too short. So we're going to want to go ahead and pump that up to be this. And we'll leave that the full size so it'll punch past the edge and keep going. There, like that. I think we're going to add in just a little bit of X so that we can get our angle a little bit less square. And what we're going to want to do now is program it so it actually does something. Fun, right? So we're going to need to know how far we want to push this. Let's go ahead and give it a float. Public float scale. Scale. Let's go ahead and give it a range of -10 to 10. And basically that will allow us to run a function where we can push the object sand, the terrain around the object. So for that we're just going to create another new function, public void push. And we'll go ahead and make that something we can add via the context menu. We'll also add a button on the inspector at some point. And what this is going to do is it's going to go through the terrain, and it's going to edit the terrain so that it has a bulge on one side of the object and a lee on the other side. In order to do that, however, we are going to need to know exactly where those points are on the terrain. So we're going to need to be able to detect any given XY coordinate as to where it is on the terrain's surface. Now, if we take a look at the terrain, in my head going over the terrain's object stuff, I've got a reference on the other side here. The terrain has a height map, width and height. And in order to get the position, we need to, let's go ahead and make a function for it. Public, we can't make a function for it though because it's, wait, we can, that's right. We can now return, these wonderful, wonderful toys. Don't know whether this is going to work though. I'm not sure whether or not, let's take a look, let's find out. Yay, it works. So I'm blanking on the term. These are called, oh, they have a very basic name and I've just forgotten it because I'm having a tired day. Basically, we can just return multiple values. So we'll be returning x and y in this way. And of course, we're going to have to pass it a vector 3. And so we're actually going to want to have a vector, just the x and the y element. We don't want to have to force it to be a vector 3. So we'll just go ahead and do it like that. So once we've got the x and the y value, we need to convert the x and the y into a tile map. Except this is backwards, isn't it? It is backwards, sort of. We'll go ahead and do it like this, but when we're actually doing the computations, we're going to have to do it per height map position rather than per world position, because we don't want to affect the same point on the height map more than once. But this will be a good way for us to test and see that we have it under control. So in order for us to figure out the position that we're looking for, we need to know the width and the height of the terrain. So we're going to go ahead and make these cached values. Now the reason I'm making them cached values is dumb, so we're not going to do that. I'm sort of presuming that it's slow and expensive. I don't have any reason to presume that, so never mind. We're going to go ahead and just do it the old-fashioned way. So when we find the width here, what we've got is height map values, and you can see that we've got a couple of different sorts of height map elements, but none of these elements are the one I expected to see. Aha, it's hidden away in terrain data. There it is. So here we've got a terrain data object where we can get the some of these values here. Now there's the size, but can I get the width and the height separately? A vector 3 size. That's not what I want. Actually, it's not a bad thing to have. Problem is I'm not 100% sure which of these values are going to be useful. So let's go ahead and just copy paste these debug.log gablamo. It's probably not what we want at the moment. It's definitely not what we want. But what we want is height map scale, height map width. Here it is. And here's height map height, unless I missed my guess. Yeah, there we are, no problem. So that gives us the height and the width, and we'll go ahead and log that too. There we are. And so that should allow us to get some values, and we're just going to go ahead and paste that. So position target dot bounds dot center dot x. and .y. All right, so when we go back over to here, hold on, I can't see the screen anymore. Mifa says tuples. Yes, tuples. That's the phrase I was forgetting. It's something that you only ever use in that one context. So when you haven't used that context for a while, you forget it. Tuples are great. They're awesome. Anyway, we're going to go ahead and do some checking here. Doop. So when we tell the LeMaker to make itself, boom, you can see that what we've got here is 500 by 200 by 500. That is, in fact, the physical size of this object. It's 500 by 500 by 200 up and down. That is not the scale of the data in the object. If we look at the actual data scale, it's probably 512. Yeah, there's the control texture. Oh, why did it come up as a $sign? I must have... Sorry, I've been using the wrong... using the wrong language for a while now. So anyway, there it is. Terrain length, terrain height, detail resolution 32. I'm unclear as to whether or not 500 is the int width or whether or not 513 is the int width. We'll have to try it and see, I suppose. All right, well, now we have the width and the height, or at least a width and a height. We might find that those are wrong. These might be wrong. So now what we have to do is we have to find the position of our xy relative to that. Now we actually have the vector 3 terrain size equals gerblomp. This is the data size, data width, and data height. And so what we're going to want to do is we're going to want to take the terrain size and we're going to want to get the data width and the data height relative to that so we know how much each unit is worth. And the way we're going to do that is we are going to take the x and the y and subtract, so float dx equals x minus terrain size dot x. But the problem is that x is not local, so we actually want the x and the y local to the terrain object. So that would be something where I guess we do want to pass in a vector 3. Vector 3, local pos equals terrain dot transform dot world to local matrix. Now we just do convert, right? Point, position, transform. I can't remember which of these goes which direction. Yeah, that's the wrong way. So we'll just pass it in the position. And that'll give us the local value. And I'm going to want to see what that is. Debug.log local pos. And if we're correct, then that should be a value that is easy for us to deal with. So what we're going to do is we're going to go ahead and take this cube. We will, in fact, add a collider back onto it. And what we're going to do is we're going to put this cube at 0, 0, 0, because that's going to be the easiest way for us to test and see whether or not we have the right position, because it should be 256-ish. So we'll just drop this box collider in here, kabloom, and then we should be able to see it. There it is. Not sure why we're drawing several circles. Oh, that's right. I told it to draw several circles. That's fine. Push. So here you can see we're at 250, 250. Great. We're in the middle of the object because we've moved it. Now, if we were to move this cube to 250x, it should be either 500 or 0. I can't remember which. Yep, 500. Good. So this is working to find the local position as expected. So then what we can do is we can divide our local position. Oh, hold on, I have to do that after we get the terrain size. Local position divided by terrain size dot x. Py equals local pos dot y divided by terrain size dot y. Is y? No, this is z. I am too used to Blender. And then over here, we can do that. So we'll just do... There we go. That should tell us that we're at 0.5.5 when we're at 0, 0. And I mean, this is basic stuff. I'm probably spending a lot of time explaining it to you when you already know it. But I'm not in the right mindset to program right now, so I'm not really running flat out or anything. So then what we can do is we can just take it here. So int data x equals data width times px, and int data y equals data height times px. And then we'll go ahead and it's barfing on those because it doesn't want to multiply an integer value by a non-integer value. So we can just go ahead and force that. Just cast it around. The funny thing is, it would actually work fine without casting. The way that it does it is exactly this. No, wait, I can't remember. I might cast the px and the py into integer instead, which would be catastrophic. Either way, that should work. And then we're just going to go ahead and barf those up. Debug.log dx dy, and it should be like 256 by 256. Grind, grind, grind. My eyes suddenly got very watery. It is becoming that really brutal time of year for people with allergies. Pushed. There we are, 256 by 256. So what we're going to need to do is just see whether or not we can edit the height of these values here. Either way, we can just return dx dy. That's all we needed to do. Obviously, we could do that without declaring them, but this is cleaner. So what we're going to do is do int x, y, and then we do x, y equals. There we are. And that's going to give us the position of our object. So now what we can do is we can edit the terrain. And this is not something that's terribly easy because of the way that the height map seems to be set. So if we were to go into the terrain data, if you take a look, oh, here's a height map resolution. Well, either way, there's not really a good way for us to get the specific pixel that we want. In order for us to actually pull the heights, we have to do set heights and a get heights. There's not really a proper way to do it. But if we take a look at the get height, we can get a specific height, or we can get many heights. Now, we're probably going to want to get many heights. We're going to want to edit them all at once, right? Otherwise, we're going to be setting dirty like a million times. But here's the thing. It's got a really weird setup. It returns a two-dimensional array where you start at a specific x and a specific y, and you go a specific width and a specific height. Why is it a two-dimensional array? I mean, I guess that's okay, but we already know the width of the array, so... or the width of the block we're trying to process, so why not use a one-dimensional array? Anyway, that's the only way to do it. So that's the way we're going to do it. For now, we can just do it with one, though. So let's go ahead and do it with just one to try it out. We can do get height and set height. So terrain.data terrain data get height. And we can just give it that x and that y. And what we can do is we can say terrain.terrain data.set height. No. Why are you fucking erroring out on me? Set height. Okay. Hold on, why is there only a plural version? Okay, so apparently we can't do that. Never mind. Float. Heights. It's a float array. Now the question is, do I have to... No, wait, that should be fine. So we'll just say heights equals terrain data, get heights. And then we'll just have it get a 1x1 array. Easy enough, right? And then we can say heights 0, 0 plus equals, and then we can pass it in our scale. And then we can use terrain.terrainData.setHeights, and we'll pass it in x and y, and then heights. What I'd really like to be able to do is get a pixels, but that's okay. I understand why they don't let me, as much as I disagree with it. So we'll just go ahead and grind for a little bit here. And basically, we're going to start somewhere where it's not going to cause us any harm if we end up making holes in it. So we're just going to move it to somewhere where there's no risk of us intersecting with this bowl we've created. And then we will just run it, push. And you can see how that's created a huge spike. Now the reason for that is because the 1 is apparently out of an alpha value of 0 to 1. So what we're doing is we're actually adding in whatever the maximum we can add because it's capped. So even though I told it to add 1, what we actually wanted it to do was add substantially less than that. And basically what we can do is we can turn this to -1, and you'll see that what happens is rather than going back to 0, rather than going back to flat, it's going to punch a huge hole down to the maximum negative value. That's because these values are between 0 and 1, not between negative, or not between 0 and 200. So what we're going to have to do is divide this scale by the vertical scale of the terrain. So this. Z? No, Y. So now that we've done that, and we set this to, say, 1, actually let's set it up to 20. Even if we set it to 10, it shouldn't really be very much. It should just be like a clip. So let's try it. Yep, see? And if we did it a couple more times, it would eventually come back up to where we are. And you might think that this is really slow, but you have to remember that this is intended to be like sedimentary stuff getting pushed around. It shouldn't be any kind of strange or exceptional situation where we're having a massive push. It should always be something fairly gentle. So even at its maximum volume of 10, we don't want it to actually push very far. So there we go. We're back to neutral here. No problems there. But what we want it to do is sort of scoop out a bowl shape. And the bowl shape needs to be a specific curve. So we're going to need an animation curve to do that. And we'll go ahead and give it a time start, value start, time end, value end. But that's just temporary, just so that we can test it, right? Because that's absolutely not what we want it to actually be. We just don't want to have any errors. So what we actually want it to do is be a flat at 0 value, right? So we're going to go ahead and put in some zeros. Maybe I should have made the default zeros, but I didn't want it to just do nothing if I ever forgot about it. Anyway, we can add in a value here and then make this go up like this. And then we can add in a value here and bring it down like this. And that should be a pretty decent sort of setup for what we're trying to do. And it's not broken. There we are. That'll do it. That's more like it. Good enough. All right, so that should do pretty well for our basic value. And so what we're going to do is we're going to want to, this size here needs to be defined by our bowl size. And what that's going to be is it's going to be the extents of our bounds. These. Int width, not int, float width equals target.bounds.extents.magnitude. And that's going to give us a value that is however long the, or however wide the object is. And it's going to take it at its largest scale. So whether this thing is wide or tall or long, we're going to get a large value. Sorry, I'm drinking something because my allergies are killing me. And one of the things that happens is it dehydrates your throat, at least for me. So we've got this width, and really it's not a width, it's a radius. So we're just going to use it, radius. It's actually a double radius, it's actually a diameter. There we are. So this is our diameter. And basically what we're going to do is we are going to take a certain amount of pixels out of our height map. And the pixels are going to be the diameter divided by the terrain.terraindata.size.x. No. Hold on. The diameter will be in meters, and this will also be in meters. Yes. I think that's going to work fine. Oh, I've already got this as float. No biggie. Let's go ahead and debug that. Debug.log. We'll just go ahead and log it straight. Pixel diameter. And basically, we're going to just not edit anything. And what we're wanting to do here is see whether or not our pixel diameter is going to be something reasonable, like this is tiny. Something reasonable when this is big. You know what? I'm not at all sure that that's actually taking. Well, we'll go ahead and see. It should be larger than 1 anyway. It is just 1, so that means there's something wrong with that approach. But it could also just be that there's something wrong with the collider not getting to the full size it needs to be. Just 1. No, of course it's going to be tiny because we're not... I have to multiply... I'm just an idiot. I have to multiply it by the actual scale here. So terrain data.size. No, come on. Size.x. Nope. Not size. Terrain size.x. Height map width. Grind, grind, grind. Now it should be more like, I don't know, 30? Let's find out. 27. So that is now working, and that's the width across this yellow ball that we've drawn, which doesn't appear to be working quite as well as I'd hoped, but that's okay. I can always adjust it later. So what we're going to need to do is just go across that much size of stuff. So instead of 1, 1, we're going to use pixel diameter, pixel diameter. The problem is that X and Y are not supposed to be at the center. I believe they're supposed to be at the corner. So we're going to have to subtract X minus equals pixel diameter divided by 2, Y minus equals pixel diameter divided by 2. The only problem is if this ends up pushing us off the edge of the height map, it might error out. I've never done this before. I'm not too concerned though. So once we've gotten the heights, what we're going to do is set them up with our system. So for int x equals 0. Oh, sorry, I can't use x because I'm already using x. We'll just use a and b. A equals 0. A is less than x. Nope, a is less than pixel diameter. A plus plus. And then for int b equals 0. B is less than pixel diameter. B plus plus. And what we're going to want to do is determine how far from the center of the map that's going to be. So in order for this to happen, we're going to need to know where the center of the map is. Good news, we already know where it is. It's X and Y. So really what we want to do is this should not be editing X and Y. So we'll go ahead and make int start X equals, and then it's going to be pixel diameter, and then we're going to do start Y. There we are. And then we'll just use start X and start Y. And then in here, what we'll do is we will do a distance measurement. So float X%, and that's going to be a... You know what? I don't need this. I'm sorry. I'm wasting everybody's time. Undo. There we are. Because all we really need to do is get the percentage. So float percentage x equals a divided by pixel diameter, but we need to make sure that these are both being cast to floats. And then down here, we're going to want to actually end up multiplying that by 2 and subtracting 1. So 2 times this minus 1. And that'll give us a value between -1 and 1. Easy enough, right? So down here, what we're going to want to do is, hold on, this isn't going to work. We actually want the world coordinate of this location. So we're going to need a new function for that. Do I want a vector 3? I really guess I just want a vector 2. But yeah, that should be okay. So what we're going to want to do here is, I don't know whether or not I can just use this same, I think I can. So we're basically going to want to just do the opposite of what we did down here, which means that we're going to take these pixel values and we're going to turn them into a world coordinate. And the way we're going to do that is we are going to get their percentage of the height map, and then we're going to end up multiplying them by the terrain size. So float x equals float pixel x divided by float terrain.terrain data.heightmap width. But we also want to multiply that by the terrain scale. Perfect. This is a very basic way to set it up. Now, the only problem I've got here is that we are... This is going to have to be a vector 3. All right, we're going to make it a vector 3. But the problem here is that we have to remember to move it. So we're going to actually need to return the terrain.transform.transform point this. There we are. That way we'll get it back in world space. So vector 3 world point equals position a plus x and b plus y. So the reason that this is necessary is because we are moving along the course of the wind. So what we need to do is we need to get how far along our wind vector this is. And for that, we're actually going to need to subtract the current position of our target. Now, this is something where we want to cache this because it's going to be expensive to keep getting it. Oh, that's not bounds extent. Yeah, that is bound extent, but we also need the bound center. Now, the reason I think this is expensive is because I'm not at all sure that the bounds are cached properly. I believe that I use that internally it automatically uses a get children and then I calculate bounds and then all sorts of nonsense. And I wouldn't normally worry about that, except for we're going to be doing this hundreds of times every time we call push, so we might as well cache it, right? So down here we're going to subtract away the bounds center, and that gives us a delta. So we now have like a laser pointing away from the, or towards the center of the, no, away from the center of the bounds. And what we're going to need to do is we're going to want to do a dot product with the vector of our wind, like this. And we're just taking the world pause and the wind. We're going to take the normalized value of the wind because otherwise our dot product will end up being a little bit strange. So this is not going to be a normalized value. The world pause is not normalized. And what that means is that it's going to be somewhere between negative bounds extent and positive bounds extent. I already cached this as diameter, so I don't know why I was caching it as something separate. Oh, that's right, because I was just not thinking straight. So we're going to go ahead and punch this in here. I needed the bounds center, and I did the bounds extents instead because I wasn't thinking straight. Anyway, the wind pause is going to be... wind pause is between negative diameter and diameter. Actually, it's radius, not diameter. And we're just going to go ahead and check that. Debug.log wind pause. And then we're not going to set anything. Let that grind for a little while, and we should get to see a lot of values when I hit push. Look at this. So you can see that it's negative 248, 244. That's too big. Why is it such a large negative number? We screwed something up. I can only presume that the world pause is wrong. Oh, you know what it is? It's the Z value. Oh, sorry, Y value. My bad. There we are. I'll clear all this before I try it again. That's better. So you can see that now it goes between 15 and negative 15, thereabouts. It looks like it's mostly positive, not much negative stuff here. But I have a feeling that's just because of where we're starting. Yeah, there's the negatives. So it's working fine, right? And what we're going to want to do is get the percentage of that. So we're going to go ahead and turn that into a percentage. So wind pause divided by equals radius. That's going to give us a value between -1. And then what we're going to want to do is get the leftovers. And that's not quite how it actually is. It would probably be better to do it in a different way. So what we'll do is we'll do a vector 3 ... But the problem is that we want the opposite of this dot product, which is not actually what you might expect. We'll go ahead and leave it like this for now. Anyway, what we're going to want to do is bring our wind position from -1 to 1 to 0 to 1. There we are. That way we can just do it on the animation curve. What did I call it? Bowl shape. There we are. And then we can simply edit the value. Heights A, B, plus equals amount. And then down here, we set it. Easy as pie, right? Only problem is that this does not take into account... Actually, it does, doesn't it? Never mind, this might work fine. Let's try it. If it doesn't work fine, we'll figure out another way to do it. So we're over here, out in the middle of nowhere, just in case, you know, we don't like the result. We're no longer pasting a billion things to the screen. There we go. And you can see that the result is expected in that it changed. But unfortunately, it looks like it changed in a way that is total garbage. So we're going to need to fix that. There are a lot of things wrong with this. So I think the easiest thing for us to do here would be to use the flatten. I forgot to divide the scale by the terrain data.y. So we're going to go ahead and use that. Go ahead and make that something we cache just in case. Oh, no, that's not what I want. There we are. So now it won't get out of control. But if you noticed, it wasn't going on the correct vector either. So if we were to run this again, rather than going along this yellow line we've created, it's going off at a strange angle. It's not even a right angle. It's just like not correct at all. And the reason for that... not sure. But if I were to do a -10 and execute, you can see how it goes back down to 0. And that's the sort of thing we want. We want that ability to completely, you know, undo our operation. So here you can see it's off by exactly 90 degrees, but it wasn't off by exactly 90 degrees. Do I have X and Y backwards? Is that all it is? I bet that's all it is. Well, this is definitely X and this is definitely Y. Yeah, you can see how it's off by 90 degrees. I'm going to go ahead and get rid of the visual on this, just so I can see a little bit better. But the problem with the wind being off by 90 degrees is that it's absolutely not. Because as we can see, if we look at this, it's not 90 degrees off. It's got the X and the Y coordinates backwards. But I don't know why. Hmm. The terrain isn't rotated, is it? It isn't. Well, just to see what'll happen, let's go ahead and invert this. Now it works. Okay. So apparently, I don't know what's going on. That makes no sense to me. But it looks like the looks like the X and Y are not X and Y, but are instead Y and X. I'm trying to think of any conceivable reason that would be. And I can't. But if I come down here and I invert this, it'll work. No? What? I don't know what's going on. No clue. Not even the slightest hint. That is super weird. But something about it is screwy, and I don't know why that is. I found a way that works, and I guess we'll just stick with it. But that's really uncomfortable. So here you can see that we've just got an exact duplicate of the line from here emblazoned here. The only problem is that it's not a proper dish-shaped bowl, but is instead a furrow. What we would like is for it to be a bowl. And in order for us to have a bowl-shaped setup, what we're going to need to do is, first off, let's go ahead and make these, this is the radius, and we won't use the, there we are. Yeah, that way it'll be a little bit bigger, and basically we're going to, we might change this later, I haven't really decided yet. Yeah, so that's more like the size I was expecting. But as you can see, the idea here is that it pushes on one side and pulls on the other. This is backwards, and I actually have it set to a negative value. But if we were to push it again, you can see how what happens is the sand pushes up on this side of the block, and then on the far side of the block, it dips down. But it needs to be a bowl shape instead of a furrow. And that's the issue. And that's going to be a matter of the weight here, wind pause. And what we should have is dot products that are very close to 0. Because if we think about the wind direction and the world position is going to be from this point here out to wherever we happen to be computing, right? And so over here on the sides, the world position should be like 90 degrees off, if the world position is actually the world position. And what I'm thinking is maybe that's what I'm doing wrong, and it's not the world position that I think it is. Let's take this position and actually just debug it. So here you can see that what we've got is a whole bunch of values, negative 120 by 22. The actual position of the cube is at negative 145, and that's close. So the negative 120 and so on, those are all correct. If we move it on the z-axis, you're going to see the z-axis is the wind axis, and the y-axis is being ignored, which is all correct. So the question is, when we actually get the world pause here, why are we getting values that line up so well with the wind position? Because that doesn't make any sense. I think I got it. So we'll go ahead and try it one more time. First, let's fix it. I think the problem is this. Because what's happening is we're getting values that are very close to here. So when the wind position is being taken into account, we're going to get values close to this if it's along the wind vector. And then in the middle, that's where we're going to get the values that are not along the wind vector. So my assumption is that what I need to do is add in a key of 0.50 that is flat. Let's just see it. Nope. No, that didn't do jack shit. See, I presumed I knew what was going on, but I was wrong. This is like exactly along the bend. It doesn't vary at all, as you can see. I'm undoing the changes we made to this curve here. There we are. Now it's back to being normal. And if I do a -5, it's not going to return perfectly anymore because I changed the values a little bit. So we'll go ahead and just flatten that out. Yoink! I didn't expect this to be so annoying. The real question is why the dot... Hold on, got my carpet folded up there. Why the dot product is producing a value which is strictly 0 to 1 when it should be... I mean, it's strictly like... Am I thinking about this wrong? Because the dot product shouldn't be... Look, like our z value is all we've got. So when it's a high x value, like this shouldn't be a 1 or a 0. It should be like a 0.3, and it should stay a 0.3, right? Maybe I need to normalize the world pause. Let's try it with the normalized world pause. Well... So what we've got here is that the value along the axis is going to always be either -1 or 1. So it's going to be a 0 because at -1 and 1, they're both 0. At 0 and 1 once it's done converting. And then it radiates out along the x-axis because that's how it works. So what we really wanted to measure was the progress along... Yeah, well, we got that properly. So let's go ahead and undo this. And we'll just flatten this out again. So we've got the correct value here. This is correct. It gives us the amount of progress along the vector of the wind, which is what we want. But what we need is the other half of that equation, where we get the offset value. So what we're going to need to do for that is to get the opposite of the wind direction. So let's go ahead and do that. Ortho wind equals vector3 dot cross product, and we'll go ahead and use the wind direction and the up. And then we'll just go ahead and normalize that. And then what we're going to need is this same here. So float ortho pos equals vector3 dot dot world pos comma ortho wind. And what that'll do is that'll get us the opposite progress. The progress, and then we'll just repeat this here with ortho pos. Wait, is that right? Yeah. So now we've got two values. Orthopos is also between 0 and 1, but it's actually not supposed to be. This one is supposed to be just the magnitude. And then what we do is we actually end up wanting to get the inverse of that. So there's got to be an easier way to do this. I'm starting to drown in math here, and it doesn't make much sense. But let's find out whether or not this works. That is not right, but it is less wrong. Oh, of course, I know what the problem is. That's where that goes. We don't want to change where on the curve we're getting the values. We want to change how strongly the curve is being implemented. That's more like it. So now you can see that we've got the right kind of shape going for us. We've got something that piles up on one side and then dips down on the other side, right? Right? That should be what we want. So let's go ahead and try it out on something that doesn't suck. We take a look. This rock here is not the one we want. We want this one over here. Rock A01 clone, this one. So if we were going to just test this to see whether or not this feels good, we're going to want to use a rock that isn't already set up. So let's just grab this guy, rock B, and move him over here, like so. And then we'll point the cube at him. And that's supposed to be the center of the bounding box of the rock because this rock is huge, as you can see. So let's go ahead and rotate this rock a little bit until it is not quite as buried, you know? There we are. So now what we'll do is over here on the cube, we'll set this to a maximum scale and we'll give it a shot. Now the wind is currently dragging along from uphill. We're getting the wind coming uphill. So it's going to be fun to see what we get when we fix that. But let's go ahead and make sure the wind isn't exactly on axis. There we are. Push. Aha! And you can see that the result here is A, too strong, but B, it's not wide enough. So what we're going to need to do is make it a much wider effect. So we're going to take out this magnitude divided by 2. And up here, when we get the actual pixel diameter, we're going to want to go even bigger. Rather than radius times 2, let's go to radius times 4. Now obviously 10 is a little too much. Let's try 3. That's a little bit better. Now the issue we've got here is that it is moving along the wind vector, which means that this rock is going to end up having an issue where the actual swell is right here in the middle of the rock, rather than over here at the front of the rock. If the rock was pointed the other direction, this wouldn't be an issue. So if we were to revert this and grab this rock and rotate it 90 degrees, and then go down to the cube, and then run it again. Oh, it's still set to negative. That's just me being stupid. So you can see that this swell is more along the lines of what we want. But even this, it's... Well, let's go ahead and drag this back. Is it still set to something stupid? No, it's fine. 3 is fine. Push. I think that this is probably going to be okay. I might come up with a better way to do it. But it's creating some weird chaff on the edges. You see this? I know why that is. Our pixel diameter isn't getting properly set up here. Since we're getting so much radius, we're ending up with much too much volume on the sides, and it's ending up creating an inverted swell on the sides, which is not what we want. So those are obviously incorrect. We'll have to revert them later on, but for now we'll just take this rock and move it someplace new so that we can do a little bit more testing. Yep. Over here. And now the wind is coming downhill, so we should see a really pronounced effect. Yeah, so even at a fairly low value of 3, we're getting a really noticeable effect. But the question is whether or not this is even the right way to do it, because it might make more sense for us to use the actual exact border of the collider. So if we have these stones, we already have their collider. It's possible for us to take the border of the collider and use that to push the sand up or down. That would create a more realistic result, and it would drag. We could have a drag along the side here so that we form a proper result. Because let me show you what a proper result should look like. If we're looking at this, we want the brush size to be like a 3. Here we are. What we want here is... Ooh, that's too loud. What we want here is this kind of result, right? Where the brush needs to pull down on these edges, because this is how it ends up being. And then it swells up here. And in fact, we want it to swell up here enough that it might actually end up like partially covering like this. But we don't want it to feel too forced. But this result is something that is much nicer than if we were to have to do it manually each time. So what we would ideally want to have is something which could automatically move the height map to have this result. But in order to do that, we're going to need to be able to detect the edges of this rock. we have the edges. We can do a closest point sort of simulation there. So what we might do... See, the issue here is that I don't want to double raise. So if I were to go and pick an arbitrary number of points around the edge of the rock and use a closest to, I could get the closest point on the rock to whatever point I was trying to edit. Let's do it. Let's try it. When worst comes to worst, I'll just waste another hour. So what we've got here is a setup where we are grabbing the world position, as you can see, and we've been using the bounds center. But instead of using the bounds center, what if we get the closest point on the object? So that would be our target collider, which I believe is called target. Yeah, target dot closest point. And we just passed the world pause. Yeah, so that'll get us a grab the closest point to the world pause. This will determine the distance between the rock or whatever it is we're doing and the point we're looking at. So vector 3 range dirt span equals world pause minus closest. This will get the amount of dirt between us and the world pause, between edited point and collider. And then what we do is world pause, we'll go ahead and set that equal to the dirt span minus the bounce center. The dirt region is what matters, not the absolute position. Only problem with this is it's not going to end up making much of a difference for digging out the sides, but I think I can edit that by coming down here into the cube and dealing with this, because I was editing this kind of arbitrarily. Oh, that's actually pretty close to how I want it. Just go ahead and drag it a little bit more, like maybe this. Now the only problem is that the dirt span is not going to be anywhere near a full 0 to 1 possibility, because the dirt span, we've been using the radius here, and that's not going to end up being valid. That's going to end up being radically stunted, but we'll go ahead and try it first. Peter stopped in to say, hello, what kind of feature are you working on? Basically, I'm trying to get these rocks so that they'll automatically bury themselves in the sand in a really realistic way. Because otherwise, I'm going to have to manually edit every single time I put down a rock. I'm going to have to manually edit the terrain around the rock. So what I've been doing is I've been making this thing which should push the sand up on one side of the rock and down on the other side of the rock. Oh, well, that's not quite what I expected. That's really strange. Let's try that again. Come on. So that ended up being backwards. I'm not sure what that was. Peter says, will the rocks be mineable? Probably not. There's no reason to mine things in this game. I just am trying to work on a visual feature, and it's not as easy as I'd hoped. You know what? I might simplify this. Okay, let's go ahead and simplify everything. So we're going to delete everything we did because it turns out that that's kind of annoying. So the dirt span determines how far we have our range from the dirt. And what we're going to want to do is we're going to break everything up into two simple ideas. The dirt is either going to be on the lee side or on the exposed side. So the wind is either hitting the dirt or going past the dirt. And that means that what we're going to want to do is determine whether the closest point is towards the wind or away from the wind. So is our closest point towards the wind or away? And for that, all we have to do is get the dot product of the closest minus the center point. So I'm just trying to figure out if this is going to end up causing us any other grief. I'm trying to think about this to make it easy. Float windness equals vector 3 dot dot wind direction dot normalized, and then the closest minus center dot normalized. That'll get us a value between -1 and 1. That's going to determine whether or not we want to raise or lower the sand. Peter says, so you're simulating it as if there was an ocean current. That's exactly right. That's how I want to make it look. So now that we've got an amount of windness, an amount of lee-ness, we're going to want to apply a vertical scale based on that. But the more dirt there is between us and the windiness, the less we're going to apply that scale. So basically, oh, I deleted the dirt. There it is, dirt span. Float dirt span equals world pause minus closest dot magnitude. How far is it between the closest point and us? Because there's less of an effect. And then what we'll do is we're going to just temporarily get rid of the bowl shape entirely. And instead what we're going to have is the windness times our scale divided by our dirt span. And we're just testing this to see whether or not it even vaguely works. So there's the direction of our current. Let's see. It was too soft, I couldn't tell. It looks like it's backwards. And it also looks like it's really, really soft. So, I guess it makes sense that it's backwards. So we'll just go ahead and invert it. And then what we have here is a setup where, you know what, let's go ahead and square it. But here, when we're dividing by dirt span, turns out this is not enough of a divisor. Maybe we should square that too. So this squaring it will end up making it a smaller value. This squaring it will end up making it a larger value because this is below 1 and this is above 1 most of the time. Is it? It might not be because a meter is a fairly large chunk of space, but we'll go ahead and figure it out here. Push. That didn't do jack. I think that what's happening is we've divided it by too much. Let's go ahead and just debug it. Let's just see if all of these amounts are 0, because they probably are. I probably borked it. Yeah, they're all 0. Look at that. So the question is, what part of this is making them 0? Let's go ahead and just do it like this. And nope. So it must be the fact that the dirt span is so high. If I was doing this bright, I would actually, you know, have a debug system set in. The Relin says, hi. Hello. I am just trying to create a dirt blown by the wind setup, and it's stifling. It's not really working very well. You can see how the further out it gets, the higher the effect gets, which is the opposite of what we want. Yeah, I'm not sure why. I mean, I know why this is happening on a crease, because that's the extent of the edited terrain. But there's a lot of stuff going on here that's wrong. And this is the same stuff that was going wrong with it when I was doing it the other way. So maybe there's something wrong with my fundamental approach. But basically, all I want it to do is focus in right here, which is why I'm dividing by dirt span, because the dirt span is the world position minus the closest position. So it's the distance between where we're editing and the rock. And it should be quite large, like 15 meters. Let's go ahead and find out. Bye, Peter. Have fun. This is actually in the middle of the day for me, so can't really stream any earlier. Here you can see that the distance is like 80s. So let's see how this is a huge, huge amount of range. But if I'm looking, I don't see any small range. I only see big range. I'm not sure. It's possible I only see 80s because, oh, you know what it is? It's the y-axis. That explains it. Now the dirt span should be very, very small, like on the order of, don't delete it, on the order of like 10. Let's clear it. Cleared. Ooh, that's better. All right, so now we still got dirt spans of like 30 at the edges, but a lot of these are down at like 10 or so, and that's more what we're looking for. Hopefully some of them are at basically 0. Yeah. Yeah, there we are. So this is correct. I mean, it's not, obviously, but this is the right idea. You can see how it's going up on this side, down on this side. But the problem is that the values aren't being properly divided. You can actually see how this is not quite right. Let's go ahead and move the rock to a different location. In case you're wondering why I'm not caring that I'm screwing up the height map, it's because the height map is super basic. It's trivial. So let's move it to here. Now, it doesn't look like the height map is being properly synced up. So let's set this to 1 so it's smaller. Let's go ahead and add a value to this. But I can't help but think it's not getting divided enough. Let's go ahead and just multiply the dirt span by itself again, now that we're no longer having a tremendous dirt span situation due to just the y offset. Yeah, so here you can see the basic idea starting to come in. We were floating above the ground, so it's not like it made any sense. No, not -4, just -1. So we're going to go ahead and do this, and then we're going to bring the rock down so that we can actually see how it looks. So this is the rock in the dirt. And if we go ahead and run this, what is the result? So you can see what happens is it digs the rock out in a way that is almost right. It's not too unrealistic, but it doesn't have any substantial positive swell. It's also got some fairly strange situations here. We have a really sharp crease. I'm presuming that what we're seeing here is a problem where the world pause is being incorrectly set up. So the problem here is that we are running with a 0, and what we actually want to run with is a bounds center. Can we do it with bounds center? I think we've already flattened it. Yeah, we already flattened it. So it's going to have to be transform.position.y. No, not our transform. Target.transform.position.y. So what that should do is find the coordinate that's closest to it on the same plane, rather than the coordinate that's closest to it on some arbitrary hell plane. So I think that most of this is being caused because the... let me flatten this. I think most of this is simply being caused because it is trying to scale it from some arbitrary point down in the basement. The Relin says, how's the new terrain editor then? Oh, well, you know, they forgot to test it, so some of it's good, some of it's bad. You may notice that my terrain is actually floating way, way above 0, despite the fact that it's supposed to be underwater, and that's because their new terrain editor only uses world coordinates for setting the height. And so if you want to set the height to anything other than 0, you have to set it to a positive number. You can only set the height between 0 and whatever your maximum value is in the terrain. But that means that my terrain is actually between 0 meters at world height and 200 meters at world height, and I can't change that by moving the terrain up and down. So that means that my water is currently at 100 meters in the air because I don't have any other options. And these are like basic features that they should have tested. In theory, I can punch holes in it now, but I haven't figured out how to do that. It might require me to update to Unity 2019.3. Anyway, let's test this again. So that's definitely more right. But you can see how the positive side isn't really happening and the negative side is silly. So there's something screwy going on. I'm not sure exactly what it is. It's close, but not quite. There's still something wrong with our setup. If we go into a -1 value and apply it again, we're going to get almost right results. But this one little spike comes up because it was past the limit of what the height map could actually represent. But I'm not sure why it's not. Oh, no, that's correct. What I really need to do is come up with a debug view. I can't tell what I'm doing. I've been working on it for 2 hours, but I am still a little bit lost because I'm doing too many transforms and doing too much complex math. Maybe I should store all these intermediate values, or maybe I should have different... Maybe I'll just leave it for now. What we're going to do is just pop off to another scene. Where are my scenes? Scenes. We're just going to go ahead and create a new scene. Goodbye. And then we're going to go back to the original scene. Hello. It's saved. Those assholes. Okay. Well, that's not too big a deal. We can still fix it. Nothing like some data errors to give your terrain a little bit of spice. So we're going to create a wobbly smooth brush and smooth this area. I was trying to do something that would save me work, but clearly I don't know what I'm doing, so it's making more work. Instead, what we're going to have to do is, oh, of course that's right, the terrain features are saved separately from the scene. I forgot about that. That's fine. So what we're going to want to do is, I believe, come up with a different way of doing that. Maybe we'll just do it manually. It's not that big a deal to manually do it. Let's go ahead and do some manually just to make sure that we sort of feel it, right? So what we're going to do is use a soft brush like this. There we are. And the idea here is we want to have a fairly obvious, like this is not an accident sort of feel to it. So, like, you know, filling in like this is sort of what I'm thinking. I wish there was a way to smooth without going over to the dedicated smooth brush, but whatever. The problem is that the lee side, previously when I was doing the lee side, I was using the same size brush. And what we actually want to use is a much larger brush because the lee side is a larger, softer gap, like this. But that means that whenever I do these rocks, I'm going to have to do two separate passes, and that's kind of annoying. So I'm not sure. We may try and do both with the same brush if I can figure out, you know, a good way. So you can see the idea is that we want the player should have, there's no mistake in the player's eyes. The player should know that this sand is like this on purpose. These rocks exist within the reality of the scene rather than being just kind of plonked on the surface. There's a lot of ways to do this. We could put in like custom shells which would allow our rocks to be associated with a bulging system. But the problem is the custom shells would have to be shaped per rock, and rotating them would screw it up because the rocks can have any rotation we want, and the custom shells would have to match them somehow. Now, putting in custom shells is not hard. It's actually the way that Abzu does it. And the basic idea is that you just have like blobs, and then the blobs become height map. And that's very, very easy. All you have to do is the same thing we were doing, except for instead of trying to set up a formula, all you do is tell it to read, do a raycast down to the blobs. And that would just be putting the blobs on their own layer and then raycasting down. And if you run into a blob, that's the height map should be. We might as well go ahead and do that. There's no reason not to. So let's go ahead and set that up. And the way we're going to set that up is we're going to go ahead and grab a rock and make a big rock. So let's take this rock and duplicate it. And we'll call this, just stick it somewhere, like off where it doesn't matter. There we are, global it. Here we are. And we want it to be big because it's supposed to be a feature, a terrain feature. You can see that the moss growing on it is automatically reorienting so that it makes sense. But this is going to be invisible in the final version, so this is going to be an editor only tag, and we're going to put it on its own layer. So let's add a new layer, and this new layer is going to be called height map objects. Can I put a space there? I think I can. There we go. So we want to go through and create our own custom height map. So let's go ahead and create a new create C# script height map staple or height map scanner. Scans scene for raycasts on the height map layer to find height map elements and set our height map. Height map. Height map. Height map. All right, so we're going to have a terrain. Public terrain. We're going to have a mask. Public int mask. And I don't actually remember how to set up these masks or check what they are. We'll just put in a random number, probably like 512. And then we're going to want to have a function which actually does all of the work. So public void scan. And then we'll just set this up as a menu item. And we'll just create an array of floats like this, which is going to be heights. And we're going to need to fill that with all of our heights. And the way we do that is we pass it into terrain. So terrain data dot get heights. And then we pass in a 0, and then a width and a height, which would be terrain data dot width, dot height map width, and terrain data dot height map height. Let's go ahead and cache those because we're going to be calling them a lot and it's long. There we go. So then what we're going to do is go through all of them and create our proper setup. Werbus says hello. Hello, Werbus. So now we've got a simple scanning system where we are going through and, oh, I forgot to set this height equals that. Where we're going through and we're going to set the height to a raycast if we can find it. But the problem is we have to determine what our height or what our position is in the world. Good news is it's actually pretty easy. We just take the X and Y and we divide them by the height to get a percentage, and then we multiply them by the actual width and position of the world, so, or of the terrain patch. So we'll just go ahead and divide this, and we're casting to floats because otherwise it will say the value is 0. And then what we'll do is we will multiply out that by the actual terrain height. So terrain data dot size dot x. Height in this case is not height, it's width, or x, and that's fine. That'll get us the X position, and then here, the same thing for the Y position. Which, of course, is the Z position, not the Y position. So what that does is we're going to make that Z because otherwise I'll forget. Excuse me. There we go. So that gives us a position that we need. So we're going to go ahead and set that up as a new vector3, x position something, z position. Now I've just done a 0, but that's not very good. We're going to go ahead and make it 500. We can change it later if we need to. In fact, why don't we go ahead and make it a public float scan from height. No, let's go ahead and just make it 500. It's fine. So then what we're going to do is have a raycast result. There it is. And we're going to do an if raycast physics.raycast position direction. I think it's then out hit and then max distance of 1,000. And that should be, oh, and the layer mask. So then the layer mask would be the mask, but I'm not sure if that's the correct setup. So anyway, if this works, if we do hit something, then we simply set our heights. Heights, WH equals, and then we, oh, you know what, I forgot. This has to be moved. There we are. So then we just set this equal to the height of our hit. But the problem is we don't actually know what the height of our hit is. So that's going to be the hit.point.y, but we're going to have to change that y position to a local position. So what we actually need to do is say vector3 local hit equals hit equals terrain dot transform dot inverse inverse transform point hit dot point, and then float y equals local hit dot y. There we go. And that's going to be the local coordinate, which is going to be any value we please, but what we need to do is get it divided by the height of the terrain. And I don't mean the height map height, I mean the height of the terrain. Like that. And that's going to, in theory, be correct. So after that, we're just going to say that height map equals y. And then we're going to need to actually set that height map back into the world. So terrain.terrain data.set height 0, 0 heights. Now, the only problem with this is that this might end up rotated 90 degrees. We've had that problem in the past, and we might have that problem now. So what I've done is I've moved this to be offset so that it's not going to be positive on both axes. See how it's negative on x? We're going to go ahead and make it, yeah, like this. That way we'll tell if it's offset by 90 degrees. Over here on the cube, we're going to go ahead and get rid of our... Oh, that's right. We didn't actually set this up because we didn't save the scene. So we're going to go ahead and set the height map scanner up here. Go in. There we are. We're going to go ahead and lock the terrain in. Now the mask of 512 is just a randomly chosen mask because I can't remember what the layer is. I think there's a layer helper. Let me go ahead and just take a quick look here. Unity layer mask helper. There we are. So we can just say that it is equal to, I'll go ahead and say int layer equals 10. And then down here, the layer mask, we'll just calculate it here. Get mask. And then with get mask, we can pass it. Okay, thank you. We pass it layer names. That's interesting. I don't want to pass it layer names. I want to pass it layer... I guess we could... I think this is going to end up screwing up. Because that's not an array of strings. That's just a one. Do I have? I'm 99% sure that I have to do something dumb. No, it's not called layer mask. It's just called mask. Sorry. Okay, so let's try it. Out of bounds. Oh, of course. Yep, see how we're not lined up properly? That was my concern, because that's the problem we had last time when we were trying to figure it out. Also, no, it seems to be a matter of it just not understanding the position it's supposed to be. But I don't know why it would be offset by... That looks like it's got the X and the Y backwards again. Why is this backwards? This is not a complicated system here. All we're doing is taking the X and then dividing it by the width. That gets us the percentage of the X. And then we multiply that. All I can think of is that this is actually stored as ZX rather than XZ, which I presume is true. It's just really dumb. Like, really dumb. Yep, that's true. Okay, I don't know why that is, but I can live with it. So what you can see here is that we get these really sharp, crisp edges because of the way that this is scanning for stuff. If we don't find something, we just kind of don't change anything, and the result is that our edges end up super sharp like this. So what we can do is we can live with that, we can smooth it after the fact, or we can come up with an algorithm that will help to smooth it as we need it smoothed. The only issue is that we don't know... I'm going to go ahead and leave it like this for now. I can always polish it later. Good news is the layer mask thing worked. So what we can do is we can smooth the height around the edges. And I'm not sure how much use this will get, but this is a useful way for us to try and get the rocks to work. The only problem is these edges. If we ever break from using the height map blobs, these stones that I've just set up over here, then we're going to end up with a lot of seams, and that's no good. If the entire map is made out of layer masked elements, then that's not going to be a big deal, because we can just layer mask everything, and there won't be any fall through. It'll just work. But the instant there's fall through, it's just going to use the default layer size, the layer height on the terrain, the default terrain height. And that means we're going to get really, really sharp edges. Now, I know that this can work fine because this is how Abzu does it. Abzu does exactly what I've just shown you. They have these blobs that they put into the scene, and those are the height map blobs that the height map uses. And so they can tilt them, and they can do whatever they want with them. Like, for example, if we wanted to change this, we could just rotate it and then move it and then rescan. And you can see that the height map is now mapped to this instead. And this is a really simple, straightforward way to do things. And it's really robust because you can have this rock be the parent object for whatever we put on top of it. And then we can move the rock around, and all of the stuff that we want on the rock will come with it. So to show you that, what we can do is we can take our mesh sprayer, and we can just massively increase this. Boom. So you can see we've got a lot of rocks, some of which are floating well off the surface because I scaled it wrong. That's fine. No big deal. We can just manually delete a few of these things. But the problem is I accidentally didn't put them inside the rock. So what we're going to do is just manually drop them inside the rock. If I'd done that more carefully, they would have been in the right spot. But now you can see that what we've got is a series of rocks on top of our rock, right? And if we move this around so that it is in a different place than it was before, and then we rescan, it will come down, and these rocks will still be right on the surface where they were before. And that means that we'll be able to do whatever we want with these rocks, and we can just recompile the scene. But that also means that every single one of these rocks has to be on a blobby surface if I want that wind-swept dirt feel. This is not a bad approach, and it's worth having at our disposal. I'm not sure that I'm going to use it. We'll find out. The real problem is, of course, these edges. They're just the worst. The other problem is that I've set this up as an editor-only object, which means that when I unpause, it's still there. Why is it still there? It's set as editor-only. Well, let's go ahead and drag the player over to it. But I think that maybe what's going on is that the fact that it has children that are not editor-only are screwing it up. Yeah, I can definitely still see it. So the fact that it has children means that it's not editor only. So what we would need to do is we might have to have some nonsense. Well, you're definitely malfunctioning. Obviously, if we have any height map objects, they can't have children because it's going to screw up their performance, which means that we would have to have a container containing the height map objects and move the container all at the same time, which is beginning to get annoying. It's beginning to get a little silly. So let's try it, though. Just move these rocks here, and move these rocks here, and name this terrain. Because another option is we can create a script that can actually do the work. We can create a script that can delete the parent rocks, mesh, and colliders, and just have it. Yeah, that's probably best. It's still here. What sort of editor-only thing is this, where it's not editor-only at all? Obviously, we would need to create a script that would get rid of the mesh collider and the and whatever renderer we were using. So let's go ahead and do that. So we don't have any on-play helper. Let's go ahead and create one. Call it on-start helper. And this is just going to be public Unity event. Oh, I have to put it in. On start and on, what's it called? Awake. There we go. That's all we needed. And this is a very, very basic setup where we can just plop this in and tell it to delete this object. There we are. So on awake. Boom. Mesh collider. Enabled off. Mesh renderer enabled off. It's a really dumb solution, but you can see that it works. Now another problem we've got is that it does not inherit the texture. But I'm just sort of playing around with level design elements here. I could have it try and inherit the texture, but I think that it would be better to not do that. To be honest, I'm not sure that this is going to ever see any use. I was trying to think about ways to do this that aren't total crap. And I think that the way to do it that's not total crap is to just do it manually. The thing I want help with, though, is populating underneath these rocks and around these rocks. But I think that'll be okay. I don't think it'll be too much of a challenge. Either way, let's delete these. Gone. And then we'll use this flat planter here. And you can see the flat planter is currently doing this. If we take a look at these rocks, these are all rocks that are on the default layer, including the terrain. The terrain is also on the default layer. But what we can do is we can put the terrain onto, you know what I just thought of? We could actually put the terrain under the height map objects layer. And that way, whenever we use the height map, it would only ever raise the terrain. But we could have some sort of weight to that. We'll figure it out later. For now, it's good to be on a different layer just so that we can target a specific layer with our mesh sprayer. So we'll go into our detail spray here. And basically, we're going to want to have a public int layer. And we'll set that to 0. And down here, when we're doing our raycasts, we're going to have a mask that is based on whether or not we are using a layer. So we'll go ahead and say 0 for now. Or what is the maximum? Well, we'll figure mask equals layer mask dot get mask. New string layer mask dot layer to name, and then this layer. I guess we'll just do it. Let's try it. Grind, grind, grind. So here, what we can do is we can set this up to only hit the... Oh, let's unplay. We can set this up to only hit the height map object layer. If we do that, then what we can do is... Oh, let's... This is actually not the one I wanted to edit. God damn it. What this is going to do is it's going to broadcast to the wrong thing, and that's not what I want. So we're going to go ahead and undo that. We'll copy. It's the planter. Nah, I'm not going to bother. Well, my voice is gone, and my throat's really starting to hurt. So this is a good time for us to stop, having accomplished literally nothing. Thanks for stopping by, everybody. If you have any questions, I'll pay attention to chat for a couple more minutes. But today is one of those days where we tried a whole bunch of stuff, and I don't think we're going to end up using any of it. but we needed to try it. We needed to make sure that it wasn't going to be of any use. I think we're going to have to do a lot of stuff by hand, and that's fine. The best levels are always built by hand, right? Hope so. Otherwise, I'm screwed. Have a nice night, or day,